Very good morning. So in today's class we are going to discuss about Thevenin's theorem statements and some problems. So let us see first what is the Thevenin's theorem statement states that. So here you can see that it states that any two-terminal linear bilateral network containing a number of voltage sources and resistances can be replaced by an equivalent circuit consisting of a voltage source which is called as V Thevenins in series with a resistance called as R Thevenins. So this means that any circuit, whenever it is having some voltage sources and resistances, then we have to resolve that circuit into its an equivalent circuit consisting of a voltage source which is called as V Thevenins connected in series with a resistance called as R Thevenins. This statement can be better understood by taking an example of a problem. So where VTH is nothing but called as the open circuit voltage VOC between the terminals A and B. It is called as Thevenin's voltage. In the similar way, what is R Thevenin's? So R Thevenin's RTH is nothing but the equivalent resistance of the network as seen from the two terminals A and B, with all other voltage sources replaced by their internal resistances and current sources as open circuit. So how you have to find out R Thevenin's means, in the circuit, if there is voltage sources with respect to its internal resistance, then you have to short circuit the voltage source and replace it by with its internal resistance, and then if there is any current source, it has to be open circuited, and the resultant circuit will have only a resistive network, and that resistive network has to be resolved in order to find out RTH, which is called as R Thevenin's, and where RL is called as any load resistance. Now we will see the diagram of a network, how to represent the Thevenin's theorem. So here you can observe this is a box which is representing linear bilateral network with voltage sources and resistances, and these two are the terminals where a resistance is connected between these two terminals, generally called as load resistance, and the current flowing through load resistance is indicated as IL and load resistance is indicated as RL. Now this is a simple diagram representing a linear bilateral network with voltage sources and resistances, and across terminals A and B there is some resistance which is called as load resistance. Now we'll see what is this network is. So here in this figure B you can see that this is a network having voltage source V, resistance R1, R2, R3, and this is the two terminals A and B where load resistance is connected. So this circuit has to be solved by applying Thevenin's theorem, and we have to draw its equivalent circuit consisting of a single voltage source that is called as V Thevenin's, and you have to solve this network, and from that network you have to find out R Thevenin's, and these two terminals A and B will be as it is, and this is your load resistance. So this network has to be solved in order to get a voltage source connected in series with a resistance, that is RTH. So this circuit we need to solve. So for that we need to follow some few steps. Let us see how to solve the circuit step by step. Right, in order to determine the Thevenin's equivalent circuit, let us take this following circuit having resistances A, R1, R2, R3 and voltage V, and these are the two terminals A and B where load resistance RL is connected. So RL is the load resistance connected between A and B. So for this circuit we need to apply Thevenin's theorem, and we have to find out its equivalent circuit having V Thevenins connected in series with resistance R Thevenins. So this is the network which we need to follow, which we need to get by applying Thevenin's theorem. So what is the step 1? So step 1, what we have to find out means, we have to find out either V Thevenins or R Thevenins. So before finding that, what we have to do means, in the network whatever it is given, you have to observe where is the load resistance. So these are the two terminals A and B where the load resistance is indicated with RL. So this A and B terminals has to be open circuited, means the load resistance has to be temporarily removed. So here you can see that A and B is the two terminals where load resistance RL is connected. So in first step what you have to means, to determine the current through the load resistance RL, temporarily remove this load resistance whatever it is connected between A and B. So whatever the resistance connected between A and B is the load resistance, you have to temporarily remove that load resistance. So after removing the load resistance, the circuit will be like this, having some voltage V, R1, R2 and R3. So these are the two terminals A and B where the load resistance is removed. So now how these two terminals are there? It is like open circuit. So the voltage between terminals A and B is generally an open circuit voltage. So these two terminals A and B are open circuited. Simply we can write this as VOC. The voltage between terminals A and B is nothing but simply VOC, which is also called as or Thevenins. So the voltage between terminals A and B is called as open circuit voltage or Thevenins. So whenever we take some parallel circuit, this A and B is parallel with this resistor ends. So in parallel circuit voltage will be same. So in our first step we need to find out Thevenin's voltage or open circuit voltage. So how you have to find out means you can find out the voltage Thevenin's across this resistor, that is across the open terminals, that is across this resistor we have to find out the VTH. So this is how you have to find out VTH, right? This is a circuit. A and B are the two terminals where load resistance is temporarily removed, and this behaves as an open circuit. So the voltage across this A and B is VOC or Thevenins. So in this step you need to find out Thevenin's voltage. So that Thevenin's voltage can be found across this resistor R3. So simply you have to represent the Thevenins as like this with arrows across R3. Now we have to find out Thevenins. Right, now in figure B you can see that this is a network consisting of R1, R2 and R3. A and B are open circuited, so the voltage across A and B is open circuit voltage VOC or VTH. Simply you have to find out Thevenins across these two terminals, that is across R3, that is VTH. Now you already know what is voltage formula. V equals to I into R. Already we have R value as R3. What is the other unknown value? Current, I. So first if you find out current, you can easily get V. This V is nothing but VTH equals to I into R, where R value is R3. If they give the R value, just you need to substitute. But what is the current form? Current, you have to find out the current. What is the current? It is indicated here. So current flowing in this branch is I1, current flowing in this I2. The following current flowing in this R3 resistor is I3. If you know I3, then simply you can substitute VTH equals to I3 into R3. From that you will get Thevenin's voltage. Right. We need to find out determination of Thevenins. Thevenins is nothing but the voltage across this resistor. That is simply written as Thevenins equals to I3 into R3. So resistance value R3 is R3. So what is the unknown value here? I3. So what is the formula for current? I equals to V by R. So simply you can write it as I equals to V by R. So what is I over here? That is I3 equals to V by R. So we need to find out I3 equals to how much? So I3 equals to V by R. So from this circuit you can observe that A and B terminals are open circuited. So the voltage across these two terminals is VOC, that is open circuit voltage, or Thevenins. Therefore you can find out that Thevenins across this resistor. So here you can observe that A and B is open circuited. Since A and B circuit is open circuited, current flowing in this path will be 0. That is I2 equals to 0. So whenever I2 equals to 0, that is nothing but there is no need to consider this R2, because R2 is also, there won't be any current flowing. Since the current is not flowing, it is behaves as an open circuit. So since I2 is equals to 0, then this figure can be redrawn for our understanding purpose as like this. So V, R1, R3. A and B terminals are open circuited, so there is no current flowing in this path. So simply we have circuit consisting of R1 and R3. Current flowing here is I1, current flowing in this is I3. So same current is flowing, right? I1 is the same current flowing. Since there is no current flowing in the circuit can be replaced as simply like this. Only we will have R1 and R3. How these both resistors are connected? Both resistors will be in series. You can observe. Simply the circuit is voltage, resistor R1, R3, current flowing in this as I1, current flowing in this is I3. How these both resistors are there? Both are connected in series. So I1 is nothing but equals to I3. Therefore total current we can simply take it as either I1 or I3, whatever it is in series, the current will be same. Right? From this circuit we need to find out current, that is I1 or I3, both are equal. So from this we can see that I3 equals to V by R. So what is voltage here? That is V. What is R? How these two resistors are connected? Both are connected in series. So that can be written as I3 equals to V by R. that is equals to V by what is our resistance? R1 plus R3, because R1 and R3 both are connected in series. Therefore, you will get I3 equals to V by R, that is V by R1 plus R3. So you got it as I3. Now we have to find out V. But simply you can find out as V Thevenin is equals to I3 into R3. So if you from this formula you will get I3 and you already have R3. Simply if you substitute the values in place of I3 and R3, you will get V Thevenin. This is how to find out V Thevenin. This is your step 2. Now we will go for step 3. Now in step 3 we need to find out RTH. So determination of RTH. So in order to find out RTH, whatever the circuit we have considered in step 1, same circuit you observe. So this circuit, what you have to do means, if there is any voltage source and if it is having some internal resistance, then it has to be replaced by its internal resistance. If there is any voltage source, simply short circuit the voltage source and replace it with its internal resistance. So here we do not have any internal resistance, simply we have a voltage source. So simply represent that voltage source as short circuit. Suppose if there is any current source, then what you have to do, current source has to be open circuited. So in this figure you can only have a voltage source. So voltage source has to be short circuited, and if there is any current source should be open circuited. So then the resultant circuit, whatever it is there in the case 1, in order to find out VThevenin, same thing will become like this. Means it will have only resistive element circuit. The circuit will have only resistors, because there will be no sources. If there is any voltage source, you have to short circuit, and if there is any current source, you have to open circuit. So from this circuit you need to find out R Thevenin. R Thevenin is nothing but called as Thevenin's equivalent resistance, that is RTH, that is nothing but total resistance. Now for this circuit you need to find out total resistance. So for our simplicity, I am making the circuit to simpler arrangement so that you will better understand how to find out RTH. So I have redrawn this figure as like this. Same resistance, whatever it is there, it is connected between this end and this end. So this end is connected over here, this end is nothing but automatically connected over here. 1 minute. So for our simplicity, I have simply represented this R1 as like this, R3 as like this, R2 as like this. Between A and B, you need to find out R Thevenin's, that is total resistance or Thevenin's resistance. So here you can observe how these both resistance are connected. They both are connected in parallel. So what is the resultant circuit? The resultant solution, R1 R3 divided by R1 plus R3. If you solve this, you will get one resistance. For that resistance, how this R2 will be? It will be in series, that is R2. This is equals to R Thevenin's. This is how to find out R Thevenin's. So in order to find out R Thevenin's, what you have to do? The circuit, same thing whichever you have considered in case 1. If there is any voltage source with its internal resistance, the voltage source should be short circuited, and if there is any internal resistance, you have to draw same thing, and if there is any current source, you have to open circuit it, and then you have to find out across A and B RTH. This is how to find out RTH. Now we got VTH. Where is this VTH? We got VTH and RTH. What does the Thevenin theorem states? That it has to be represented with an equivalent circuit consisting of V Thevenin's, that is VTH, in series with RTH. So this is the equivalent circuit of Thevenin's theorem. V Thevenin's in series with RTH. Now whatever the resistance we have neglected during the initial process, that is here, the load resistance whatever we have removed here, between A and B, now that has to be replaced over here. So whatever the resistance A and B, across A and B, whatever the load resistance is there, bring that and connect over here, that is R. Now this is your total circuit. So for this circuit you need to find out current flowing through load resistance. So RL is the load resistance, so current flowing through load resistance will be IL. You already know what is, how to find out current. I equals to V by R, something I equals to V by R formula. So what is V here? That is V Thevenin's. What is R? That is both the resistances are connected in series, RTH plus R. So this is how to find out the load current. IL equals to V Thevenin's by R Thevenin's plus R. From that you will get the load current IL. So this is about the superposition theorem. Now we will solve a problem for better understanding. So this is a given question. For this question we need to apply Thevenin's theorem, and find out current across load resistance, and also draw its equivalent circuit, equivalent Thevenin circuit. So what is your initial step? Step 1, removal of load resistance. What is the load resistance? This is the load resistance. So in step 1 you have to remove the load resistance between A and B. Then the circuit will become like this. So what is your step 2? You need to find out VThevenins. So determination of VThevenins. VThevenins is nothing but the Thevenin's voltage between terminals A and B. That is VOC. So across this A and B we need to find out VThevenins. So that is, you have to find out the Thevenin's voltage across R3 ohm resistor. So you already know what is formula. V equals to I into R. Means already R3 value it is there. What is the other term we need to get? The current flowing in this 6 ohm resistor. So let us first indicate the currents. So current flowing in this branch as I1, current flowing in this branch as I2, current flowing in this branch as I3. Since A and B is open circuit, the current I2 is equals to 0. Then how the resultant circuit can be drawn? This is the resultant circuit. Since I2 equals to 0, there will be no current flowing in this path. So I2 equals to 0. So what is the remaining circuit? That is R1 and R3. How these both resistors are connected in? Both the resistors are connected in series. Why I3 equals to I1? Because both are connected in series. Current flowing in series circuit will be same. So from this we need to find out I3 or I1. Both are same itself. So I3 equals to V by R. So what is voltage? 9. What is resistance? So we have to take R3 because sir, you can ask that we can take R3. But what is the total current? The current is flowing is same in the total circuit because R1 and R3 are in series. So what will be the total resistance? That is R1 plus R3. That is 9 by 3 plus 6. That is 9 by 9 equals to 1 amp. Therefore this is I3 equals to 1 amp. So from here you can find out VTH. VTH equals to I3 into R3. What is I3? That is 1. What is R3 value? It is 6 ohms. So VTH equals to 1 into 6 equals to 6. Units is volts. So therefore VTH equals to 6 volts. This is your step 2. Now step 3 you need to find out determination of RThevenin. That is RThevenin. So for that you need to consider the same circuit whichever you have considered in case 1. So whenever there is a voltage source you need to short circuit, and whenever there is a current source you need to open circuit. But here we have only voltage source. Voltage source has to be short circuited, and this network should only consisting of resistive elements. So R1, R2 and R3. So between A and B terminals you need to find out RThevenins. So RThevenins is nothing but the Thevenin's equivalent resistance. So how this R1 and R3 are connected? They are connected in parallel. The resultant will be connected in series with R2. So the equation can be written as R1 R3 divided by R1 plus R3, since these two are in parallel. The resultant is in series with this. So if you solve that, you got 4 ohms. So therefore you got R Thevenin is equals to 4 ohms. R Thevenin is equals to 4 ohms. So we got V Thevenins and R Thevenins. Now we'll represent that with an equivalent circuit. So how Thevenin's theorem, Thevenin's equivalent circuit is represented? V Thevenin 6 volts in series with R Thevenin's 4 ohms. The dotted portion represents the equivalent circuit. And now finally the load resistance, whatever it is connected between A and B terminals, you have to bring it back and connect to the circuit. So now we have to find out current through load resistance IL. So what is IL equals to formula? So IL equals to V by R. So V Thevenins divided by R Thevenins plus RL, because both are connected in series. If you solve that, you will get IL equals to 0.428. So this is how to solve the Thevenin's theorem. So we'll see few more problems based on Thevenin's theorem. So this is a question. Using Thevenin's theorem, find the current through 3 ohm resistor of the following network shown in figure. So this is the following network. So we have to find out current through 3 ohm resistor. So in this network, the 3 ohm resistor is at this place. So this is already having some open terminals. So across here we need to find out the current through 3 ohm resistor. So what is first step? We already know that remove load resistance temporarily. So since in this problem that person has given that this is the 3 ohm resistor, already it is shown with open terminals. So let us consider this one as load resistance. Let us remove this load resistance temporarily. That is what we have written statement here. Remove load resistor temporarily. So here let us consider 3 ohms, which is already an open circuit terminals, to be the load resistor. Now find the now the figure can be redrawn as. So this 3 ohms resistor itself we can consider as load resistance. Now how I am drawing the figure is redrawn as this 3 ohms is sent over here. I mean 3 ohms is not neglected, and these terminals are replaced as A and B. So this A and B open terminals are shifted here, and 6 ohms is shifted here for our convenience. So after redrawing, this is A terminal and B terminal. This is 6 ohms resistor, 4 ohms voltage source, and 2 ohms. So because of this voltage source, there will be some current flowing in the branches. So that current flowing in this branch is I1, in this branch is I2, in this branch is I3. So this I3 is again divided as I1 in this branch and I2 in this branch. So what is our step? Second step, we have to find out Thevenin's voltage across open terminals, that is A and B. So A and B are the open terminals. So here we need to find out Thevenin's voltage. That is nothing but we have to find out across the 6 ohm resistor. So this figure represents the Thevenin's voltage across 6 ohm resistor. So we already know V Thevenin is equals to current into voltage. So what is the current flowing in this? It is I1. So I1 into 6. So what is the unknown term? Unknown term is I1. So if you solve I1, you can simply substitute V Thevenin is equals to I1 into 6 ohms, so that we'll get the Thevenin's voltage. So now what we have to find? We have to find out I1. Right, now we'll find out I1. So how these two resistors are connected? Since I1 is the current flowing through 6 and 4 ohms, these two will be in series. So that is replaced as 10 ohms. And this is 2 ohms. And I1, I2 and I3, whatever the current directions we have earlier considered, same thing. So here I1 is flowing through 6 and 4, both are connected in series, both are added, 6 plus 4 is 10. So in this network, how these 10 and 2 ohms are connected? Both are connected in parallel. Means R1 R2 divided by R1 plus R2, that is 10 into 2 divided by 10 plus 2. If you solve that, you will get a single resistor and this voltage, right? Then from that you can find out total current, that is the total current flowing from this voltage is I3. So if you find out I3, you can find out I1 and I2 accordingly. So what is the total resistance from this circuit? These two resistors are connected in parallel, that is 10 into 2 divided by 10 plus 2. If you solve that, you got as answer as 1.67. So this is your total resistance. Now what is the current? I mean, if you solve these two, you will get a single resistor and this voltage source. From this circuit, you can find out total current I equals to V by R. What is voltage? 8. What is R? That is 1.67. If you solve that, you got resultant as 4.79. Now what is our aim? We need to find out Thevenin's voltage. That is V Thevenin's across 6 ohms. That formula is I1 into 6. So what is the term we need to find out? I1. So for that case, current through 6 ohm resistor is, that is current through 6 ohm resistor is I1. So I1 equals to what we have got? We got total current as I3. So I3 we have got I3 into the opposite resistor to 6 is 2, that is 2 divided by sum of all resistance, that is 6, 4 plus 2. 6 plus 4 plus 2. So if you solve that, you will get current I1. Therefore, V Thevenin is equals to I1 into 6, that is 0.798 into 6 equals to 4.8. So you got V Thevenin's. Now what we have to find? Next step, we need to find out R Thevenin's. So in order to find out R Thevenin's, the main circuit, whatever it is given, so let us consider this one as a main circuit. So whenever you are finding Thevenin's resistance, voltage sources has to be short circuited and replaced by internal resistance. And if there is any current source, open circuit. So here 8 volts is the voltage source. So simply we can short circuit this 8 volts and there is no internal resistance, so we can neglect it. So what happens? 8 volts is short circuit. That is nothing but that is having 0 resistance. So 0 resistance into 2 ohms, both are connected in parallel. 0 into something is 0 itself. So what happens? The circuit can be resolved as this A and B terminals as it is. Here you will have 6 ohms, here you will have 4 ohms. And 6 and 4, how they will be again? They will be in parallel. So if you solve that, you will get total resistance as 6 into 4 divided by 6 plus 4. I think you can understand from this figure. Right? This is the open circuit terminals A and B. 6 ohms is here. This is already 0 into something is 0 itself, so neglect that. Whenever there is a short circuit parallel with that resistor, you can neglect this path. So simply replace this with 4. So now how this A and B terminals, across A and B terminals itself, we need to find out R Thevenin's. So R Thevenin's you need to find. So R Thevenin's means how the total resistance both are connected in parallel. So for your simplicity, I have drawn this. So if you solve that, 6 into 4 divided by 6 plus 4, that is equals to 2.4. Therefore, Thevenin's equivalent circuit is, already we got Thevenin's voltage as 4.8 connected in series with the resistance R Thevenin's, that is 2.4 ohms. This dotted line indicates a Thevenin equivalent circuit. So what is the open circuit resistor over here? That is nothing but load resistance. What is its value in problem? It has been given as 3 ohms, right? You can observe here. 3 ohms is the open circuit resistance. So that is called as load resistance. Bring it over here and attach it to the circuit. Now in the question he asked us to find current through 3 ohms. Therefore IL is the load current equals to V Thevenin's V by R, V Thevenin's by R Thevenin's plus RL, because they are connected in series. So if you solve that, you will get IL equals to 0.888 amperes. I mean 888 amperes. Now we'll see another problem. Obtain the Thevenin's equivalent circuit with respect to the terminals A and B of the network shown in figure. So obtain Thevenin's equivalent network of the terminals A and B. So here if you observe, this is 10 volts, 5 volts, 5 ohms and 10 ohms. In between there is A and B terminals connected, and with respect to these terminals we need to find out Thevenin's equivalent circuit. So what is first step? Remove load resistance temporarily. There is no load resistance, so just we'll assume this A and B terminal to be some open circuit terminals, that is A and B, or load resistance. So we can consider this as a load resistance. Next, what is second step? We need to determine the V Thevenins. So what I am doing means, these two terminals, whatever it is there, across these two terminals we need to find out V Thevenins. So this is V Thevenins. Simply we have redrawn the same circuit itself. We are representing V Thevenins. So for our simplicity, I am redrawing this circuit because V Thevenins has to be found across A and B. So there is no parallel resistors across A and B. So it is difficult. So for that purpose, I am redrawing this circuit as like this. So bring this A to outside and B terminal to outside. So I have brought A outside and B outside. And remaining 5 and 10 is arranged like this, and 10 and 5 is arranged like this. So now what are the terminals? We need to find out Thevenin's voltage across A and B, right? So A and B are these two terminals. So V Thevenin's equals to, what is the opposite resistor? 5 ohms. But here there is also some potential. So what we have to do? We have to find out V Thevenin's, that is current into resistance. If you find, it is simple, but there is some voltage source also here. So what we have to do means, so we have to find out the current in complete branch. Then you can get, you have to neglect this potential, and total V Thevenin's voltage can be obtained. That is V Thevenin's equals to the voltage drop across A and B terminals, that is 10 minus drop across 5 ohms, that is minus 5 into I. 10 volts minus 5 into I. 10 minus 5 into I. What is I value? You can write the KVL equation here and you can find out I value. That is loop direction, current direction, both are same. So minus 5 into I, that is minus 5I. Here also loop direction, current direction same, minus 10I. Potential plus 2 minus, so minus 5. And if you come here minus 2 plus, that is plus 10. So 10 minus 5 is 5, minus 10 minus 10I minus 5 is minus 15I. From this you can solve I equals to 0.33 amperes. Simply bring that value and substitute over here, you will get V Thevenin's. We have found V Thevenin's. Now determine R Thevenin's. So in order to determine R Thevenin's, what we have to do? In any circuit, if there is any sources, they have to be short circuited. Suppose voltage source short circuit, and here the voltage source is short circuited. So short circuited, short circuited. Simply this resistor 5 and 10, how they will be? They will be in parallel. So find out R Thevenin is equals to 5 into 10 divided by 5 plus 10. That is equals to 3.33. Therefore simply he asked us to find out Thevenin's equivalent circuit between A and B. So between A and B, Thevenin's voltage is 8.33 and the total Thevenin's resistance is 3.33. This is how to represent the Thevenin equivalent circuit. Right? Thank you.